Now we're going to make the jump from quadratic equations to trigonometric equations that are quadratic in form. Some of these will look familiar as I'm going to reuse a couple of our equations that we did just earlier. First one, I'm looking from 0 to theta is between 0 and 2 pi, inclusive of 0, not including 2 pi. We have 2 sine squared theta minus 5 sine theta plus 3 equals 0. And if we're thinking algebraically, we could just replace the signs with x's, and that would give us 2x squared minus 5x plus 3. If this scares you as it is, just replace the signs with x's for a moment, and then we'll come back and replace them again later. This is factorable, just like the exact same quadratic we factored in the previous video. We can factor this to be 2, let's change colors, 2 sine theta minus 3 times sine theta minus 1 equals 0. And just like before, we have our zero factor property, which says the only way this can be true is if the first factor, 2 sine theta minus 3, is equal to 0, or if our second factor, sine theta minus 1, is equal to 0. And we continue solving, we get that sine theta equals 3/2, or sine theta equals 1. Now, the first solution we have here, sine theta equals 3/2, this is an extraneous solution. It's a bogus answer. We cannot have, there are no values, no numbers we can plug in to sine for which we'll get a number bigger than 1. So this is not possible. So we can ignore that solution. The only solution we have here that is sensical, that makes sense, is sine theta equals 1. Looking at our unit circle, we're looking at where the y value, that's our sine, where the y value is 1, and that would be at pi over 2. So theta here, the only answer that makes sense is that theta equals pi over 2. Looking at our next one, 2 sine squared theta plus 3 equals 4. We did do one like this on the previous video. This is easily done with the square root property. And to use that, we would take the subtract 3 from both sides, giving me 2 sine squared theta equals 1. Divide both sides by 2, and that gives us sine squared theta equals 1/2. Now we use our square root property, and that tells us if we have something squared equals something else, then the thing that's being squared, the sine theta, is going to equal either positive or negative square root of 1/2. Now the square root of 1/2, it may not be obvious, is the same as 1 over the square root of 2, but that's the same as the square root of 2 over 2. And the only reason I rewrite it this way is because that's a number that we recognize from our unit circle. So now, if sine theta is equal to either positive or negative square root of 2 over 2, let's look at our unit circle. Again, sine theta is our x value, is our y value. And that's going to happen at, it'll be positive square root of 2 over 2 at pi over 4, as well as at 3 pi over 4. And it will be negative square root of 2 over 2 at 5 pi over 4 and at 7 pi over 4. So in fact we have 4 solutions to this equation, and that is pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Alright, last but not least, we have one of these uglier ones where we have to use the quadratic formula. 3 cosine squared theta minus 4 cosine theta minus 2 does not factor. Again, we can rewrite it with an x instead of the cosine theta if that helps you to be able to visualize whether or not it can be factored. This cannot be factored, so we would end up using the quadratic formula. In this case, our quadratic formula, we've got x equals negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. Instead of x equals, though, it's going to be cosine of theta is equal to, and when we plug all those in, we get 4 plus or minus the square root of 40 over 6. So cosine of theta is going to equal 2 plus or minus the square root of 10 over 3. And as I said, we're going to need to plug this into a calculator because we don't know an angle with this cosine value. It just isn't one of the values that we've learned on our unit circle. So when we plug this into our calculator, and we did this on the previous video, we would have gotten that cosine theta must equal approximately 1.72076, or cosine theta must equal approximately negative 0.38743. As on the first example, this 1.72076 is not a valid solution for cosine theta. Cosine theta has to be between negative 1 and 1. So this is not a valid solution. We can ignore that one. We do need to figure out what theta is for cosine theta equals negative 0.38743. So let's think about this a little bit. We've got our unit circle, and we're going to, if cosine theta is negative, that means it's either going to be in the second or the third quadrant. And when we know that the two angles are going to have the same reference angle, and I like to call my reference angle alpha. So I'm going to plug this value into my calculator, and I'm going to take the inverse cosine of it, and that will give me an initial value, a theta here. Then I'm going to have to use that to come up with my second theta, which will be an angle that comes around to here. And again, these two will share a common reference angle. So let's look at that. Check my mode. I'm in degrees. I want to be in radians. And inverse cosine of negative 0.38743. And it gives me a value of 1.968638557. Again, round to whatever decimal place you're indicated to do so in the problem. We'll say that this is 1.969, I think it's probably 4 places, 968, let's see, 9686. Alright, and that's this angle over here. To figure out what my reference angle is, I need to take a half circle, which is pi, and subtract off the 1.9686. So pi minus 1.9686. It gives me a reference angle over here. This alpha is 1.172992654. So to find out my other angle, the one that's down here in the third quadrant, I'm going to add the 1.1729965 or 2992654. I'm going to add that to pi, And that gives me a second angle that is 4.3146, rounded to the 4 decimal places.